Okay, hello everyone. Can you see the screen and hear me?
Yes.
Okay, nice. So we will start in a couple of minutes. Let's just wait for some time. And while we are waiting, I could make some reminders. So, project design stage, the due date hasn't changed. So, we have still like 4 more days. And for this, the task is really simple. So, I hope you don't need more time. And basically, we expect you to fix your ER diagrams if you have any problems. And like most of the groups, we had only some minor problems. Just look at the feedback, fix those little problems, and then we want you to create this relational schema, which describes the attributes of your tables and the primary keys and foreign keys. So today someone like send an email asking whether there is some change in the due dates. So for now there is no change in the due date of design stage because it's really a simple task. You can like arrange some Zoom meeting and handle it in like half an hour or so. We assigned the homework too, and today the lab is going to be about like more advanced SQL queries, and it's related a lot with homework 2. In homework 2 we have this given database schema, and we want you to write these queries using SQL. So not relational algebra but with SQL. And today we are going to do some similar examples. And with this one, just write it on some separate documents. It could be a Word file, the answers for the answers. But if you have access, you can try to implement this database, put some entries in it, and test your SQL queries. So you are not required to do so, but to check whether they are working right or not, you might use those tricks. So you can use access to test your SQL queries. So for today, if you have access installed on your computers, it is better to follow. But if you don't have it, it's not a big deal. We send you some neat instructions on how to download access on Microsoft Azure, but it works only for Windows computers. So if you don't have a Windows computer, still you might try to install a virtual operating system, but it changes according to what operating system you are using now. So if it's Mac or Linux, etc., you need to like search for how to install a virtual operating system on those operating systems. And then if you need the Windows license in Microsoft Azure, there is also Windows 10 education version license. So if you follow these instructions, in some part we are looking for the software access, searching for access. Instead, if you search for Windows 10 in this step 9, then you can get the Windows license from there using your Bilkent accounts. So it is again free. You can like use it on any of your computers. Other than that, we will be recording the labs, but I'm using a different software. I'm not recording through Zoom, therefore you are not seeing the recording sign in the Zoom, but this software works more stable for me. While you are listening, it is better to keep your microphones muted, because otherwise we could get lots of static, so it could distract people. but when you want to ask something, you are free to interrupt me at any part. So don't forget to like unmute your microphones in that case. And the recordings, I'm going to send them on Friday or this night it could be. So for both sections we are recording, and I will publish them. Actually, I have one of them on the schedule. So if you want to check the other section, if you are curious about what happens in the other sections, you can do so. So for today, we have this example database. So if you are using Access, you can download this Access database. And we have a bunch of query questions. So basically, we are trying to implement SQL queries for each of these questions, let's say. And if we open this database, since it is downloaded from web, I need to first enable the content in it to be able to use queries or to edit some of the data in it. And basically we have 4 different tables in this database. And if you open some database that you did not implement, to see a summary view, it is better to go under database tools and into the relationships view. Then you can see the relations among different tables. And I have also the ER diagram that corresponds to this setup. So in this database, we have a bunch of students. So for each student, we are keeping the name, surname, age, and payment. So students are paid something like a scholarship. There are student groups. So for student groups, we have different group names. And using this in-group relation, we are storing which students in which groups. So because of this total participation on the student side, I know that every student should be in exactly one group because of this one-to-many relationship. So as students can be in just one group, but in a group there could be many students. And because of this total participation, I know that every student should be in this relation, meaning that a student should be exactly in one group. And in every group, there should be at least one student. Because of this total participation on the group side, I know this information. But there can be many students in a group. And we are also keeping track of the leaders of the groups. So in each group, there is a leader. One of the students is the leader of that group. And we are keeping this information with this relation called head of. So the head, the leader of that group. And we know that there could be only one leader in one group because of this one-to-one relationship. And on the group side, we have total participation, meaning that in every group there should be exactly one leader. But not every student is a leader. Some students are not leaders. Remember, sometimes we can decrease the number of tables when we go into the implementation. In the ER diagram, we always use these relations. All of our entities relations are there. But when we are going into the relational schemas or into the implementation, to reduce the number of tables, we can combine some relations. So if a relation is one-to-one or one-to-many, we can somehow combine it with the corresponding entity. So for example, for the relation in group, we know that every student is going to be in some group. And it is exactly one group. So instead of keeping the foreign keys in a separate table, I can somehow, let's think it as I reduce the size and combine it with the student. So in the student table, I can directly keep the foreign key that references the group number. So if we check the student table here, we will see that we have group number. So I know that every student should have a group number. I made this required. Additionally, this acts as a foreign key that references the S group table. So I see 2 different instances of the student table. That's because I need to create 2 different relationships. So for the head of relationship as well, we are decreasing the number of tables. So I combine it with the group entity, because if I were to combine it with student, not every student is a leader. So I would have many entities that have this attribute null in that case, since there is no total participation on student side. But on the group side, there is total participation, meaning that every group is going to be in this relation. Since it's a one-to-one relationship, I can combine it with this entity, meaning that in the group, I'm going to keep some foreign key that references the student table this time. So if I check the S group table, there is an attribute called group head. So we are keeping the ID of the student that is leader of this group. And to create two different links, so one is in one part, so if I go into there, in one part I'm combining the relation with the student table, and for the other one I'm combining it with the S group table. Since I need to create two different links, I introduce two different instances of the same table. So in this relationships view, if I right click and click on show table, I can bring as much as instances of the same table to create like different links among them, but it is referring to the same table. It is not different tables. But to create two different links, I need to introduce multiple instances. So I'm going to just hide these by right-clicking on the table names. And remember, while we are creating these relations in the relationships view, we should start dragging from the entity into the relation, etc. We had some rules. In this case, the part that I include the relation acts like a relation. So for the in-group part, I'm starting dragging from S group into the students. So in here, if I didn't have this link, so let me close all the tables, for example, for now, because if those tables are open, I cannot create a link it in between. So let's say if I didn't have this link, so this is saying which student is in which group. I'm going to click on this link and delete it, click on yes. So while I was creating that link, I started from S group, because in this part, S group acts like the entity. So that group should exist first, so that a student could belong to that group. So on the left side, I see the S group. The group now is matching with the student's group number. So that's how I created those links if I reduce the number of tables. Otherwise, it is simple. We direct from entities into relations, or from parents into children, or from the inner relation towards the aggregate relation, etc. We wrote those in earlier labs. For the works in relation, it is simple. We drag from S group into the foreign keys of the relation. And for the head of, we just reverse the order. This time, for some student to be able to become the leader, that student should exist first. So for this link, I was dragging, starting from the ID of the student into the group head of S group. This time, that student should exist first in order to assign him as the leader. And we also have projects assigned to groups. So multiple groups could work on the same project, and the same project could be assigned to multiple groups. And these are like, so there are some descriptions about the project, but basically we uniquely define the project using the number, and some descriptions could be the same. There are some budgets for each project. Also, in the works in table, we are keeping track of which group is participating in which project, etc. So let's go into the queries. If you missed the last lab, we started creating SQL queries directly. So to create a query, we were going through create and then query design. And using this dialog, we are able to create queries using QBE, which was query by example. But instead, now we are going to close this dialog and right-click on the query tab and go into SQL view. So by directly writing the SQL code here, we can run some queries. So the most basic one was to select everything from one of the tables, maybe that is the student table, let's say. And under this design tab, I have the run button to run the query. And this is my results. So I can write any query using this SQL code. And if I would like to go back into the SQL view, I can right click on the query name and go into this SQL view. But while I'm writing here, it is sometimes problematic to see the like indentations. To make the indentation in here, you cannot use the tab key. Therefore, to visualize it in a better form, I'm going to use Notepad++. So instead of writing the query directly in here, so if you are just writing the query, you can just write the query in here. But to visualize it in a better form, to be able to use like the tab indentations, and there is also in Notepad++, if you go under languages, there is a coloring format for SQL as well. So it will be more presentable for you. Therefore, I'm going to first write the queries in Notepad++, then I'm going to copy it and paste it into Access and then run it for you to be able to see it in a better way. Now let's go through our queries. So for the first one, we need to list name, surname, and group name of all students. But we would like to order them according to the group name first, and then by the student name within each group, because the group name, so in the same group there would be multiple people. We first order them according to the group name and then according to the student name. In the homework as well, sometimes we say list, sometimes we say find. If such words are occurring, that means that we need to make projection. But sometimes we want you to update things. In that case, we need to use update queries. If we need to delete something, we need to use deletion queries. So be careful about that, whether we are showing something or changing something in the database. Now I need to show something. So I would like to show the names of the students. So I'm going to open the relationships view to see the names of the attributes as well. I need to list the name of the students, meaning that project the name of the students. The attribute name is sname in that case. I need the surname as well, and I need the group name. So if I look into the student table, the group name is not in the student table. The group name is included in a different table that is related to the student table. So for now, let me just write the group name here as well. But if I'm just getting them from the student table, I don't have the group name. If I try to run this query, it will give me an error saying that, okay, what is group name? It thinks group name is a parameter. So if I just write the value of it, it will be the same for every of these students. But instead, we would like to make a join operation. And remember, if we are to include multiple tables in here, so the second one, let's say, I'm also including the S group table. If I do it, so when I run it, it makes a Cartesian product. So if we have multiple tables projected, it always makes the Cartesian product, meaning that every student is matched with every other group. So I have 7 different groups if I look into the groups table. And for each of the students, for example, Diego is matched with all of the groups, Hal is matched with all of the groups, etc. So I see the record count is there. It is the multiplication of the counts of student and group tables. But instead, I would like to make the join operation. So it is going to be a where condition here. And to make the join operation, I can check the relationships view about which attributes are matching. So between the S group and the student, there are 2 different things matching. I can join them according to the group head and ID of the student, or I can match them according to the group numbers. And in this case, since I'm looking for groups and the students that are in that group, I should match them using the group numbers. Otherwise, I'm looking for the leaders of the groups, but I'm now looking for the members of the groups. So I should put a condition saying that, okay, from the student side, the group number, the group no, should match with the group no of S group table. So this is going to be my join condition. Now if I run it, I will see that for every student there is just one group. So this is this group that this student is a member of. So in some of the groups there are like multiple or let's say 5 or 6 people. In some of them there are 3 people, etc. So I have the things that I need to project, but I also need to order them. And we had that keyword order by to do that. So after order by, I can put a list of attributes that I want to order the entries accordingly. So I want to first order them according to the group name, and as the second item, I would like to group them according to the S name. And if you like change the order of the projection, then these column orders will also change. Maybe I would like to show the group name first. It could look better. Now let me copy this, go into the SQL view of the query, paste it and run it. So I see the group name and the group names are in order. And I also see that within a group, the students are ordered according to their names. So this first one is done. If you have any questions, you can ask. Is there any problems, etc. Otherwise, we can just continue. Okay, so now don't forget to also, if you are like implementing your database for the project, you need to save your queries as well. I'm going to save it and let's give it the name Q1 for question 1. And then like we can close it on the left part. If I click on the tables, now it is just showing me the tables. But if I click on all access objects, it is going to show everything that is saved in this database. I think the default option is to show everything. Now I see my query by right clicking and going into the design view. I can see it in the design view, or if I just double click on the query, it will automatically run and display the results of this query. So now for the second one, let's look at that. I need to list name and age of student doubles. So now we are talking about some analyzing operation within the same table. I need to list name and age for students, okay, but these students occur in doubles, so there are 2 different students, and those 2 students should have a 5 years of difference in their age. So I'm going to look for 2 different students, and if they have an age difference of 5 years, then I'm going to project them, otherwise not. So let's go into this view. So this time I would like to, select the S name and age of a student. But if I say, from the student table, it is just looking at just one student, right? If I get the student table, it is just one student. I know that if I include more than one table, it is going to be a Cartesian product. But if I use the same naming, it doesn't allow me to, because otherwise, so there are 2 different instances of the same table, but I don't have an option to refer to one of them. So because they have the same name, then I need to give different names to those instances of the same table. So now I have 2 different tables coming from the same table, 2 different instances called S1, S2, and in both of them there are S names and ages. So in the projection part as well, I need to define which table this is coming from. So if any attribute occurs in multiple tables in the query, I need to mention which table this attribute is coming from. Let's also project the one from S2 side. So there are two different students. Because of this list of tables, it makes a Cartesian product among them, and I'm listing the one on the S1 side and the one on the S2 side as well. If I go through create and then query design, I'm going to close this dialog, go into the SQL view and paste this query. If I run it, I see that it is a Cartesian product among the student table. Every student is matched with the first student, with the second student, etc. Now I have some condition. So I want these double students. So there are tuples, right? Two students. They should have a 5 years of difference in the age. So my condition is going to be for ages. So let's write var. On the S1 side, let's say age minus 5 should be equal to the age of S2. I can also like include the minus 5 on the other side as well. It doesn't matter. So right now we are saying that S1 is the older one and has a 5 years of difference with S2. If I go back into the SQL view, paste it and run it, now I see the student tuples who has 5 years of difference in their age. Any problems, questions about this one? Okay. Now let's go into the third one. I need to list all group names as well as the average payments of each group. So if I look into the relationships view, I know that group name is included in S group, but there is no information about the payments within a group. So the payments are in students. The students are getting payments, but for each group, the members of that group, we would like to find out the sum of the payments within that group, the average payment. So in a group there are multiple students, they are getting paid, and we would like to find out the average payment of the students within the group. And for each group we are going to display this average payment. So let's start with some query. Again, it is a projection problem. We would like to show something, and this time let's say we are selecting, we need the group name, right? Yeah, group name, and also we need some parameter for the average payments. Remember we had aggregate functions. If we are using the group by operation, we are able to project the aggregate function results. So in this case, I can project the average payments. But now, which tables these are going to come from? Okay, for the group name, I need the S group table. And the payments are in student table. So I have to get two of these tables. And to make a join operation in between, I need to say that, okay, for the members link, the group numbers should match. So I need to say, okay, from S group side, I have a group no, and it should match with the student.group no. But I would like to group these accordingly as well. So in here, if I say, okay, group according to the group name, for example, group by, we had the group by keyword. According to some attributes, we are able to group things. If I were to say, okay, group them according to the group name, join these two tables, show the average payments. Let's do this query. I'm going into this create query design, into the SQL view. If I run such query, okay, I have the group name as well as the average payments of that group. But in this instance, our group names are unique, but there is no specific condition for group names to be unique. So if I look into the group table, I have the primary key, it is the group number, And if you are grouping something, it is better to use the unique attributes. Otherwise, you will combine some irrelevant groups. So let's say, okay, I have a group called party, but I can have two groups called party, let's say, because group name is not unique. It is not a part of the key in our S group table. So the last results were like this. In the party group, I have this average. In the number one group, I have this average. I guess we replaced some awesomes. Okay. Now we are renaming the awesomes as party. So we need to run this query again. But if I go back into the SQL view under the design tab, if I run it now, then for party, just now I'm seeing some weird symbols. It is because the column is not wide enough. If I make it wider, I see that for party, the averages is not right? So the average is wrong because it is combining two different groups. They are called party, but since I'm not grouping according to the primary key or according to a unique attribute, it is combining the groups in a wrong way. So okay, then I can make the grouping operation according to the group number, and since the group number is included in both student and S group, although we know that they are going to be equal, I need to specify which one I'm using because it is coming from two different places. I have to explicitly say which table it is coming from, but since I make the join operation, I know that they are going to be equal. I can use either one of them. But if I'm using the group operation based on the group number, then I cannot project the group name directly. So if I go back into the query, now if I try to run it, it is going to give me an error saying that group name is not part of an aggregate function. So we basically had a rule for group by operations. If we group them according to some set of attributes, then the projection should make, or let's say it like this, okay. The things I project should be a subset of things I group by, plus the aggregate functions. So aggregate functions, I can include them, but other than that, if I'm projecting something, it should be the thing that I group by. I can group by according to multiple things, so I can also include here the group name, for example. And then it is going to first group them according to the group number and then according to the group name, so that we can project the group name. Now we can also project the group number as well if we want. So if I run such query, going back to my query, pasting it under the design tab, I'm going to run it. Now I see two different instances of these groups called party. They are called the same group, but their IDs are different, and I see a different average for both of them. So be careful about it. So for questions, if you need to project the attributes, you should include them under the group by part. But be careful, if you are grouping something, it is better to use the unique attributes. To solve it, we can also like make some additional joins, etc. In the further questions, we are going to need them. Right now, we don't need to make it like that. So in here, I can first group things according to the group number. There is no problem with that. Okay, if you have any questions, you can ask. If not, let's continue with the fourth one. Or sorry. Yeah, fourth one, okay. So now again, we are going to project things. List name and payment of students that are in the group which has the highest sum of payments. So we need to use some subqueries for that. So with subqueries, within parentheses, we can define some result sets. So any query could become the subquery. And let's try to do it kind of incrementally. Now the first part is we need to calculate the sum of payments within a group. If I look into the relationships view, if I'm just interested in the groups of students, if I don't need the names of the groups, I can do operations just on the student table. So in here, I can say, okay, from the student table, let's select the sum of payments. So the P is small, I think. The sum of payments from the student table. If I just write it like this, let's try with the new query, create query design. I'm going into the SQL view. If I paste it here, if I run it, it is going to be the sum of all payments. It is not considering the groups. But if I want to consider the groups as well, I need to use the group by operation. So I'm writing group by here. And the thing I need to group the students is the group no. So if I were to group them according to something else, then I need to write that attribute name. For example, if we had the city or the birthplace of the students, and if we would like to group them according to that attribute, then I need to write after the group by keyword that attribute. But this time we would like to group them according to which group they are a member of. So writing this, if I come here and run it, now I see the sum of payments for each of the different groups. And among this, I'm interested in the maximum one. So remember, in the question, it says that I need to find the group which has the highest sum of payments. These are the sum of payments within each group. I need the maximum of it. So going back to our query, this is going to be a subquery now for me. And to do that, I use the parentheses in between. And I'm searching for the maximum value within this result set. So since it's a projection of the groups, right? I can get multiple things. This is a result set. So any result set could act like a table. So if I had some table that I need to find the maximum value, I can write select maximum of something from some table. So attribute name comes here, the table name comes here. And instead of a table, I can use a result set as well. So this was my result set. So from this result set, I'm saying find the maximum of what. So I need to specify the name of the attribute. And in this case, since I calculated using an aggregate function, if you look at the results, it is saying that, okay, it's some expression 1000. To give it a name, I need to write as something. So I'm going to give a column name to this result. Let's call it maybe the pay sum. And then I can write for this maximum operation, okay, in this result set, I have a column named pay sum, find the maximum of it. So now if I run this query, it is going to show me the maximum sum of payments. But it is not showing the group ID. So I have the maximum amount of payments, but I don't have the group ID. Why? Because I grouped them according to the group number, okay, but I only get the payments. I have the highest sum of payments. Now I need to find which group is getting this amount. So for this one, let's say I'm interested in finding the group number. And I'm again looking at the student table. I again need to use the group by operation because I'm not interested in the students individually. I'm just interested in the groups. So we need to group them according to the group number. But for groups, I need to put some conditions. If I were to put conditions for individual entries, for individual students, I can use the where condition. But if I would like to put some condition for the groups, and if I want to use some aggregate functions, I need to use the having keyword. So by saying having, so it is going to first create the groups, group the students according to the group number, And then within each group, using the having keyword, I can calculate the maximum of payments. So I'm saying that, okay, from the student table, group them according to the group number and find the maximum payment for each of the groups. And I can write, if I know the absolute maximum payments, I can write such query. If you don't think about the other part, I can say, okay, group the students according to the group number and find for each group the payments, and the payment should be equal to 500 for it to be projected. But instead of writing this number directly, I'm going to use the results of some other subquery. So this is going to be my subquery now. I'm putting the parentheses, so the whole thing is my subquery now, and it is going to be the value that I search for. So this is something like that. We already ran this part, right? So out of this, there comes just one value. I know it because I'm using the max operator. Max operator just returns one thing. With the sum operator, if I have groups, it returns the sum within each group. But in this subquery, I'm not using the group by operation. In this subquery, I'm just using the aggregate function maximum. It is going to return one thing, therefore I can say, okay, this should equal to that. If this was returning some result set, I need to use the keyword in. For now, I know that this is going to return just one value, so I can use the equals sign here. This is going to find the group number who has the, in here we need to look at the sum, right? So sorry about that. So I need to, within each group, I need to look at the sum of payments, and that sum of payments should be equal to this result, which gives us the maximum of the sum of payments. So now if I run this query, I'm going to see 5, meaning that group number 5 is getting the maximum sum of payments. So the group, the students in group number 5 are getting the total maximum payment. But we are not finished. So okay, I have the group ID now. I need to list the name and payment of the students that are in this group. So we know that in each group there are some students, and for this group number I need to project the student names and payments. Again, this time this whole thing is going to become my subquery. Remember, from here we just get the group number. If I were to just project the names, so S names and the payments of the students, without thinking this subquery for now. If I were to get these from the student table, I can again group them, right? Group by group number, or I don't even need that, right? If I know the students group number, if I'm interested in projecting some students within a group, I can just put this where condition saying that, okay, from the student table, group number should be equal to 5, for example. This is the query we need, right? So from the student table, get the S name and payments, and those students should be in group number 5. But instead of saying, writing this number directly, now this number is going to come from the result of this thing that finds us the group number. So this is my subquery, and this subquery could return more than one value, right? Because we are projecting group numbers. So if there are multiple groups with the same amount, I'm going to just run it for this version now and then show why it's wrong. So if I paste this query here, if I run it, it will work. the group number 5 was getting the most payments, and these are the students in that group. But I'm going to now go into my student table, and for, let's say, for groups 3 and 4, there are 3 students in both groups, and I'm going to make the sum of payments the highest for both of these groups. So if everybody is getting 500 in groups 3 and 4, these groups will be the maximum payment ones. Now if I go back into my SQL view to run the query again, if I try to run it, now it gives me an error saying that at most one record can be returned by this subquery. So because of the data in the previous version of the students and payments, this subquery was returning just one result. I was able to use the equals sign there. But because of the nature of this query, it may return more than one thing, because I'm grouping things and making a projection, right? The instance that I know it will return just one thing is when I don't use the group by operation, and if I'm using the aggregate function like maximum, sum, etc. If I use the aggregate function plus the group operation, it could return multiple things. And in here again, the same thing is applicable. So I need to use the keyword in because it could return more than one value. So now if I update it like this using the in, now I see that okay, these 3 are coming from group number 3 and the other 3 are coming from group number 4, and they are displayed. And in such query maybe we could also like show the group number, etc. So let's project also the group number at some part, let's say. So I see that okay, these are coming from different groups, and these are the students and their individual payments within each group. Do you have any questions, problems? So we have 4 more. Do you need a break or should we just continue and finish early? What do you want? You can write it in the chat or so. So one person wants the break, one wants to continue. Okay, then let's give 10 minutes break and then we will continue. Meanwhile, if you have any questions, you can ask. Otherwise, let's continue at 40, okay? 240. So for homework 1, we gave it to the grader, and whenever he reads the homework, the grades will be announced. Okay.
Ben daha hızlı olması için buradan sorabilir miyim acaba?
Tabii, sor.
Tamam. Bu sanırım YÖK'ün açıklamasına göre bu dönem tamamen online gerçekleşecek ya.
Evet.
Midterm için ne olacak bu konuda bir bilginiz var mı?
Yani hocalar onları rektörle falan konuşuyorlarmış. Belki olmama ihtimali de var midtermlerim. Yani benim aldığım derslerde de hoca açıklama yaptı.
Tamam.
O tarz bir şey olacak olursa belki daha ödevlere falan ağırlık verilebilir vesaire.
Tamamdır.
Hı hı. Yani hani şu an için tam belirli bir şey yok ama haber verirler yani o konuda.
Tamam, çok teşekkür ederim.
Önemli değil.
SQL View'i bir gösterebilir misiniz?
Tamam. Şu şekilde.
Sağ ol.
Önemli değil. Shall we continue? Okay. Now let's continue with the fifth one. Now we would like to list the name, age, and payment of students who are paid more than their group leaders. So again, we are doing some kind of inspection, right? Similar to question number 2. With question 2, we were looking at the student tuples, and for two students, so for student combinations, basically I have two different students, and there was no rule for those students. So these two students could be just any of the students. But now I have some rule for two different students. Okay, I have again two students, but one student should be the member of a group, and the other student should be the head or leader of the same group. So if we start to write something, let's say, okay, we are going to project things. We are going to project the name, age, and payments. Let's write those: name, age, and payments for some students, so from the student table. Again, I need to compare two different students. I need two different instances of the same table. And for these students, one of them is going to be the member. The other one is going to be the head. So let's say as member. And for the other one, let's say as head. So there are two students. One is the member and one is the head of the group. And the information about who is the leader of which group is inside the table S group. So I also need the table S group to be able to find the head of a group. So I'm going to also include the S group table. Since I have just one instance, I don't have multiple instances of this table. I don't need to give a name to that table, but I can also give if I want to. Since I'm including three different tables now, I need to specify the join conditions. And if we look at this relationships field, I see that, okay, this is the member, and from the group number, I can find the matching groups, and through the group heads, I can find the matching leader. So I'm going to make two different join operations, and they should be appearing at the same time, so I'm going to combine them using the AND logical operator. So from this S member side, so name is S member for this member student, the group number should be matching with the group number of S group. So from the S group table, the group number should be the same with this member's group number. And I have additional join condition. So the ID of member, so S head, sorry, not the member, the leader, the S head, its ID should be equal to the head ID within the S group table. We are basically saying that, okay, on this S head side, this should be the head, the leader, and on this S member side, this should be the member student. These are my join rules, and on top of that, I'm interested in the ones, the members that are paid more than their group heads. Okay, I have the leader and the member on one side, and the member's payment should be higher than the payment of the head. So I'm going to add it as an additional condition, saying that S member, the payment attribute of S member should be strictly larger than the payments of S head. So S head dot payments should be the smaller one. And these are going to be the students that are paid more than their group leaders. And again, sname is included in both smember and shead tables. I need to specify which attribute I'm using. So this time they are different things. One is the member, one is the leader. Then I need to write the table names of those attributes. And let's also do it for the leader. So let's say I'm going to project the information about the member as well as the leader. So we are displaying all this. Okay, we have a typo for group ads. Thank you. Now this is our query. I'm projecting name, age, and payment of both the member and the leader. I make the required join operations, and my condition is for the payment of the member to be larger than the payment of the head. If I go into the database, create a new query, go into the SQL view, I'm pasting it here, and if I run it, now I see that, okay, these are the members and these are their leaders, and if I look at the payments, the members are paid more than these leaders. And if I want to show the group number as well, I can do so. So I can write, okay, in here I already know the group numbers will be matching since I make a join operation on top of it. I can just mention one of the group numbers at some place to project it. Okay, these are from the group number 1. The leader of group number 1 is Diego, and he is paid 45, and these are the members that are paid more than him, and these are their payment amounts. Do we have any questions, problems? Okay, so for the 6th one, now we would like to update some attributes in our database. So it is saying that double the payment of members of the group who has the lowest sum of payments. So we need to make an update query, but this update query will not work for every student. So we are not doubling the payment of every student. We are doubling the payment of some specific students. So let's start with some update query. With update queries, in here. With update queries, remember we use the keyword update. So instead of saying select from some table, we just directly write the update keyword and then the table name. And the value that I need to update is in the student table. So it says double the payment. I need to update the payment of the students, and the payment is included inside the student table. Then I need to update the student table by setting some attributes. So in the student table, I have the payment. I can say, okay, set the payment to a direct value. It could be an operation defined on some of the attributes. So I can say something like, okay, every student is paid the amount calculated with doubling their ages, etc. Or I can say, okay, for the existing value of payment, multiply it with 2, and then this is going to be the new payment amount. I can set such rules. If I run this query, it is going to work for every student. But I need to put some conditions, otherwise it is going to update for every of the students. I can put some conditions. I can say, okay, for the students who are in group number equals 1, for example, I can write such queries. And I can also define a set of numbers here, right? In that case, if I'm defining a set of numbers, I need to use the keyword in. So if you look into the handout from last lab, there are such usages. So I define a set of things. In this case, these are numbers. If I were comparing using strings, I need to include the quotations as well in a list of items. And to show that this is a list of items, we use the parentheses, and using the keyword in, now this is going to update for the students who are in group 1 or 2 or 3. But now, instead of writing it directly, I would like to double the payments of members of the group who has the lowest sum of payments. So in some group, the sum of payments of all students in that group is the lowest. And I need to find the ID of this group and pass the ID in this part. We have done some similar things. So if we remember, for the query number 4, we found the highest sum of payments and we found the group ID of that specific setting. So this was the query. So we were first looking at the sum of payments for each of the groups, and then we were selecting the maximum payments amount within each group. So this is actually, it would be better to write it like this maybe. This is a part of that. So in this one, we first look at the sums of each groups and then find the maximum of it. Instead, now we are interested in the minimum of these sums. So I list the sum of payments for each of the groups and get the minimum one. And then I find the group number which has the sum of payments equal to this amount. And then out of this one, I will get the group number with the least payments. So it was saying that the group who has the lowest sum of payments, and this ID is going to be the group with the lowest sum of payments. So I'm going to copy this part. And remember, we were talking about I can write a set of IDs, group numbers, in here, in this part. Instead of writing it directly, I'm going to use a subquery. So I know that out of this subquery there will be some group numbers. It could be more than one because we are using the group by operation and we are projecting the attribute directly. So we are not just showing the results of some aggregate function without grouping. So we have the grouping and we are just projecting the attribute. So there can be multiple groups with the lowest payment. So if the lowest payment was 0, for example, for some of the groups, for all of those groups, this result set with it will be returned within that result set. So I need to use the in operator again. I'm not using the equals sign because this is going to return a set of results. It can return more than one thing. But other than that, for the students, I just check whether the group number is equal to these or within these result sets. If it is in that result set, I'm going to double the payment. So this is going to be my query. If I go into the query design, create some new query, go into the SQL view, and okay, I pasted too much. I should get it here. And if I run it, now it says that you are about to update 4 rows. I'm going to click on no for now, and let's see first which group is being updated. So I'm going to delete the update part, get rid of the parentheses that covers this subquery. Now if I run it, I see that, okay, group number 7, it is the least paid group. So if I look at the students table, the ones in group number 7 are these people. They are paid like 45, 150, etc. And going back to my query, going back to the SQL view, I'm going to paste the original version again, and I'm going to run it now. I'm about to update 4 rows. If I click on yes and go back into the student table, now I see that, so previously it was 45, these are doubled for group number 7. And now if I go back into the design view of my query, sorry, the SQL view of my query to rerun it again, actually we don't need to go back into the SQL view. We are already in the SQL view because this is an update query. It is not showing any results. So with the selection or let's say with projection queries, when we run it, it displays the set of results. It goes into the datasheet view. With update queries or deletion queries, insertion queries, etc., it is not showing a set of results, therefore we stay in the SQL view. So I'm going to go under design view, design tab. I'm going to just run this query. Now again, I'm about to update 4 rows. If I click on yes and check the student table, I will see that this time it updated for some other group, because since we doubled the payment of these students, it is no longer the least paid group. Some other group just updated, and if we run it like multiple times, we will see that. So this time we are updating 5 different people, meaning that, okay, it is not the same group, it's a group with different member count. Any problems, questions about this? Okay, now with the 7th one, we need to project again. It is not an update query. We are interested in listing the name, age, and group name of students who are in the group or groups, because there could be multiple groups, with the most member count. So we would like to find the member count of groups and find which group has the most member count, and then we would like to show the students that are in that group along with the group name. Again, actually this is kind of similar to this one. So remember, in this one we were finding the sum of payments for student groups. So I'm going to, for now, just copy this one to like experiment on it, going create query design, closing the dialog, going into the SQL view. With such query, I'm able to find the sum of payments. Let's don't rename it for now. If I write here count, then it is going to count for any given attributes. For now, it is saying payment. So if I look into the student table, every student has a payment that is not null. But if I were to have some values, if I have some null values for the attribute payments, and if I say count payments, then it is not going to count the null values of payments. So it is basically saying that count the non-null values of this attribute. But if I would like to count based on the entries itself, so if I would like to include the entries as a whole when I'm counting, I can use this star symbol here as well. So if I say count star, it is going to count for the entries, and whether I have some null values for some of the attributes or not, it is not going to matter. So this is going to show me the member count within each group, since we are using the group by operation as well here. So right now, instead of saying sum, we wrote count, and not for a specific attribute, we are counting the entries as whole. And let's say instead of saying pay sum, now this is going to be like something like member count. So I name this column as member count, let's say. Otherwise it is called some expression, it generates a column name, but to be able to refer it more easily, we are giving names to the columns, and in this case we named it as member count. Going back to this query, so within this part we calculate the member count of each student group, and we are interested in the ones with the most member counts. Again, we are maximizing. So in here we are going to say, okay, find the maximum of the column that we renamed as member count. It is going to give me the maximum member count. And in this having part, so we were grouping the students according to the group numbers instead of looking at the sum of payments, because now we have the counts. I'm going to say, okay, this is going to be the count for each group. Again, we group the students according to the group number, get the count, and if the count is equal to this result, and I'm using the equal sign because I know that out of this query there will be only one result coming. So if I indent it right, So this is one of my subqueries, and in this one it is kind of similar to writing something like this, right? I can write the table name, and within that table name find the maximum. Instead of a table name, I use a subquery, and within that subquery the result sets get the maximum one. It is just one value, and find the matching ones for the group number. These are the groups with most members. So out of this result set I will have the group number of the groups with the most member counts. And on top of that, I would like to list the name, age, and group name of such students. So this time I can, if I were to like just show the name and age, so instead of the payment I can write age here. If I get this one as my new query, going back to the SQL view, if I run it, okay, these are coming from the groups with most members. I'm not seeing the group ID now. Let's also project that, going back to SQL view. So next to sname and age, let's also show the group number, the group ID. When I run it, I see that, okay, in group number 2 and 6, there are 5 members. So these groups are the ones with most members in it, and these are the students in those groups and their ages. But now I also need to show the group name. The group ID is not enough for me. I need to show the group name of such students. But the group name, if you remember, is included in the table S group. So I need to make a join operation. So I have the students, I just need to join them with the S groups. Going back to my query, okay, I was using the students. I will also include the S group table. Since I include more than one table, I need to write the join condition as well. So I'm going to write it as the first condition, because like I can still use it with the AND keyword at this part, but to make it look better, I will write the shorter one as my first condition. And it is the join condition, right? The student's group number should be equal to the group number that is in S group table. And the other condition is for group number to be included within this set. So this is my query now, and now I can write here, instead of saying group no, I can just get the group name. Going back to my query into the SQL view, I paste it and run it. So we have some problem. It is saying that group no could refer to more than one table. Let's check it. So I have this group no. It was previously working, but now since I include more than one tables, it could come from in any of them. I know that I make the join operation, that then I can use either of them. So I can say sgroup.group no, and saying student.group no is the same, because I know that I only look for the equal ones. I make the join operation, but the system doesn't know that, so I need to specify which one I'm using. So pasting and running it, now I see the students and their group names instead of the group ID. Any problems, questions about this one? Let's then continue with the last one. So for the last one, we are going to use the projects. So it is saying that list each project number, description, and budgets, along with the sum of payments of the students who are in a group that works for that project. So if we look at the ER diagram, we see that some groups are working on multiple projects, and on the other way is some projects. For some project, let's say there could be many groups working, and a group could work for many projects. And for this one, let's say we have some group working on a project. We would like to group them according to the projects, not the student groups. So let's say if we look at into our students, we see that okay, Diego, Hal, Daisy, etc. These people are in group number 1. And for example, Jill, Dan, etc. These are in group number 2. And if we look at into the works in table, we see that group number 1 is working on project number 1. And group number 4 is also working on project number 1. So for the same project, project number 1, there are 2 groups working. And within these groups, I will have some students. And for this project, to calculate the sum of payments, so I want to calculate the sum of payments of the students that works for that project without looking at the group. So these groups are working on that project, so I need to calculate the sum of payments of the students in group number 1 and also calculate the sum of payments of students in group number 4 and add it up. So combination of that. Now let's start writing it. Again, this is a projection. I need to list the project number, description, and budgets. These are included in the project table. So directly in here, I have the project number, description, and budget, but I don't have the sum of payments. So let's start writing it. Let's start by the easier ones. I need the, if you look at here, I need the project number, also the project description, and also the budgets for the project. And these are coming from the project table. Then I need to make the join operation among here. So in each project, there are some students working. So if I include the works in relation here as well, works in, I can join them, right? Using the project number. If we look at into the relationships view as well. So I can join using the project number. I can join one project with a student group, the group number. And in this view, I can also see that group number in works in is matching with the group number in S group, and it is also matching with the group number of the students. The S group table, I'm using it for group name and finding the leaders of the groups. If I'm not interested in those, then I can directly join the table works in with the table student because they are using the same matching attribute. So this is a match among 3 of these. So if I'm not interested in the name of the group and the leader of the group, then I can directly join the table works in with the student table. So let's do that. So project works in, and if I also include the student table, then my join conditions are going to be, so on the project side, the project node should match with the project node of works in. So I'm going to write project node. It should be equal to works in dot project node. And for the other tables, works in and student, I want the group numbers to match. So I should say, okay, from the works in table, I will have some group node this time, not the project node, because these are the students, so they are in a group. They work for a project through the group. So without a group, a student cannot work for the project. There should be a group. And from the student side, I'm going to say, okay, for the student, the group number should match with that one. Let's see what happens. For now, let's also include the S name and surname of the students, for example. I'm going to create a new query close this, going to SQL view, paste it and run it. So project node could refer to more than one table. For our projection, since project node is in project and works in tables, I need to specify which one I'm using. When I run this, so I will see that, okay, these are the students. These students are working for project number 1, for example. And we are not making a separation for the groups. So for example, let me check a project. Okay, project number 1, for example. Project number 1, these students are working for project number 1 and they are from group number 1. But I have some more students who are working for project number 1. But if we check like Sui, Liam, they are from a different group. So they are coming from group number 4. So right now we don't have the separation of the groups. We don't need that. We just separate them according to the project numbers. And going back to our query again, remember we need to separate them according to the groups. So I am able to show the project number, description and budgets. I can show for each group the sum of payments of the students, but I need to group them according to the project number this time. So I can write group by according to the project node. But if I write it like this, now we will have some problem, right? If I'm grouping according to the project number, I can project the project number, okay. We are already projecting it. But for the others, I cannot project them directly. But I can project the aggregate functions. I can write in here saying, okay, sum of payments. So if I run it like this, I see that, okay, I have 5 different projects and these are the sum of payments that are of the students that are working on that project within a group. So without the distinction of the groups, the students are working on this project and this is the sum of their payments. Now to get the description and budget, I need something else, right? We are right now getting, okay, the project numbers and the sum of payments. Let's call this sum of payments something as well. Pro sum, let's call it, because it's the project sum, not the group sum. If I update it like this, it is going to call the column name pro sum as well. But I need an additional join. This is going to be my, let's say, result set now. This is going to be my subquery. It returns a result set. And I can make a join operation using this result set. The things that I would like to select, let's keep it for now, but they are going to come from this result set. Okay, I know that this result set returns me the project number as well as the project sum. But for the other things that I need to project, the description and budget, I need the project table. So I'm going to say, okay, this is going to come from the project table and additionally from some other table. And remember, result sets could act like tables. I know that this returns a result set. To be able to refer it later, I'm going to give a name to the result sets. So I'm able to give names to the attributes for the columns, but I'm also able to give names to the result sets. So for tables as well, we gave some names. While we were giving the name to the table, we didn't use the keyword as. We can use it still. But for the result sets, I'm going to write as. So this result set is, let's say, work groups. I call this result set work groups. It is similar to a table. So if I'm including it in the from part, it is going to make the Cartesian product by default. And if I need to join them, I need to specify the join condition. But for now, let's write the select part. So I would like to show the project number. I would like to show the description, project description, as well as the budget for that project. and the prosum. So this is called prosum since there is no any other attribute in some other table with the same name. I can just directly write prosum. Also for the budget is only included in the project table. In the work groups result set, there is no budget. There is only the project number and the prosum. So for the project description as well, I can just write it directly. I'm projecting the project no. The project no could come from the project table or from the work groups. There is the project no that is projected. But the project description and budgets are only included in the project table, and the prosum is only included inside this result set called work groups. Let's run it like this for now. Going back into the SQL view. Now I see that, okay, for every different project, this is project number 1, the project sums are matched. For every project and for every prosum, we have a Cartesian product. But we don't want the Cartesian product. We would like to join these two things. One of them is the table, one of them is a result set, and they have a common part. So we have the project number in the work groups and the project number in the project part. So I would like the project numbers to match. So after this part, I will put a where condition saying that the project node of the table project should match with the project node that is in this result set called work groups. So these project nodes should match in order to make it sense. Then I will be showing the related prosum for each of the projects. And the thing that we are doing is because after this subquery in this result set, because of the group by operation, I can only project the project number as well as some aggregate function results. Other than that, in here I cannot show the project description, although I have the project table in this part. Therefore, I need to make some other join operation as well, defined with this condition. So now if I run it like this, going back to my SQL view, now I see for each of the different projects, I see the sum of payments that are working, of the students that are working on that project. So for project descriptions, it is not unique. We can have the same name, but we are grouping according to the project node. Therefore, this is the unique attribute. Therefore, it works. Otherwise, if we were to group them according to the project description, for example, then the education ones would be combined. This is not the question asks. So the question is asking for each of the projects to be like individually grouped. If it was saying that, okay, group them according to the description, then we can just group them according to the description. Then, for example, in here, we can like make some operations comparing the budgets and the prosums, etc. So do you have any questions, problems? So we are going to put the query answers as well. So for these questions, the queries that I wrote, we are going to put it online. So the recorded labs will be also available on the course website. So for the lab yesterday, we have the link. When both of them are available, I'm going to send you an email also for the answers of these queries. And for the homework 2, these are like kind of similar to the questions in homework 2. You should be careful about whether it asks you to project things or to update or delete, etc. And when you are using the group by operation, be careful about the rule saying that if you are grouping according to something, then the things that you project should be a subset of that plus the aggregate functions. So if you are careful about those, then it will be, I think, simple. If you don't have any questions or problems, we are going to finish here. So no questions. Then see you later. I'm going to... İyi günler, görüşürüz. I'm ending the meeting. See you. Thanks.